Hello and welcome to XP Actuarial's introductory video series, Math Refresher Part 1. Today we'll cover various mathematical topics that are used as background knowledge to a lot of the questions on the exam. We'll start off with the quadratic formula. Now assume we have ax squared plus bx plus c, a polynomial. Now we want to find the roots of this polynomial. So the equation to find the roots, or the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. This comes up in many SOA questions and is often part of at least one question on the exam. Now we'll just give a refresher on exponent math. Now assume you have x to the n to the power of m. Now that's simply x to the n times m. X to the 1 over n is also equal to the nth root of x. X to the m over x to the n is x to the m minus n, and x to the n times x to the m is x to the n plus m. And now we'll cover another topic that might come up on the exam, which has to do with limits, and it is L'Hopital's rule. So assume we have a limit of a ratio of two functions, f of x and g of x. Now assume that if we take the limit of these two ratios, we get an indeterminate form of type 0 over 0 or infinity over infinity. If that's the case, we can show that the limit as x approaches a of the ratio of f of x to g of x is the same as the limit as x approaches a as the first partial derivative of each function. So let's show a quick example here. Let's assume that we have the limit as x approaches 1 of ln x over x minus 1. Ln at 1 is 0, and 1 minus 1 is 0. So we do have 0 over 0. So we can apply L'Hopital's rule. We take the derivative of the top, which is 1 over x, and the derivative of the bottom, which is 1. And now we can put 1 in, and we get 1 over 1 all over 1, which is simply equal to 1. Next we'll cover derivatives and go over the product rule and quotient rule as a reminder to everyone. Suppose that we have the derivative of a product of two functions, f of x and g of x. This is equal to f of x, g prime of x, plus g of x, f prime of x. With the quotient rule, we have the derivative of f of x over g of x, and now that is equal to g of x, f prime x, minus f of x, g prime x, all over g of x squared. Now some common derivatives that often come up on the exam are the derivative of e to the x, which is simply e to the x, the derivative of ln x, which is 1 over x, the derivative of x to the n, which is n x to the n minus 1, the derivative of 1 over x, which is negative 1 over x squared. You can think of this as the derivative of x to the negative 1. So we bring the negative out front, and then we get x to the negative 1 minus 1 is negative 1 over x squared. And finally, sometimes we get the derivative of a to the x, which is simply a to the x ln a. Now another thing that might come up is the chain rule. So suppose we have a function that is actually f of another function. So when we want to find the derivative of this, or f prime x, it is simply equal to f prime x, g of x, multiplied by the derivative of g of x. So suppose we have an example. Suppose that f of x is equal to ln of x cubed plus 1. Now the logarithm function comes up a lot on this exam. Now f prime would be simply 1 over what's in here, so x cubed plus 1, multiplied by the derivative of what's in here, so 3x squared. Now another example could be if f of x is the square root of x cubed plus some constant, let's say 1. Now f prime x is simply, what we can do is we can actually rewrite this as x cubed plus 1 to the 1/2. So applying the logic from here, we'll bring the 1/2 out in front. We get x cubed plus 1 to the negative 1/2 multiplied by the derivative in here, which is 3x squared. Now moving on, we'll cover some common integrals. Now the exam sometimes uses integrals, and the most common that show up are the integral of x to the n dx, which is equal to x to the n plus 1 over n plus 1. Another one that commonly shows up is e to the x, so integral of e to the x dx is just e to the x. Another one that shows up with the exponential function or time value of money functions is the integral of e to the cx. Now that is equal to 1 over c e to the cx. Sometimes we get the integral of a to the x dx, which is simply equal to a to the x over ln a. And finally, sometimes we get the integral of 1 over x dx. Now that is equal to ln x. Sometimes we get a question that requires the substitution rule, or U sub. Now this rule states that the integral of f at g of x, g prime x dx, is equal to the integral of fu du. Now let's use a simple example here. Let's suppose we have the integral of e to the cx dx. Well, we can let u equal cx, and then du is equal to c dx, or dx is equal to 1 over c du. So we substitute our values in, and we get the integral of e to the u. Now dx is 1 over c du, and that becomes 1 over c e to the u. Substituting back in u, we get 1 over c e to the cx. And the final topic that I'll cover today is integration by parts. So suppose we have the integral of u dv. That can be written as uv minus the integral of v du. Now it's often easy to write it out like this: du, u du, dv, and v. So you specify something for u, find the derivative, specify something for dv, and find the antiderivative. So let's go through an example. Suppose you want the integral of t squared e to the t dt. With this, we're actually going to have to perform integration by parts twice. So we let u equals t squared. Du will be 2t dt. dv will let e to the t dt. And that means that v is equal to e to the t. Now applying our integration by parts rule, we take uv, t squared e to the t, minus the integral of v, which is e to the t, du, 2t dt. So now we need to apply integration by parts to this. So we let u equal 2t, and then du is 2 dt. And we let dv equal e to the t dt, and then v is equal to e to the t again. So now we can substitute this in. We get t squared e to the t minus uv, so 2t e to the t, minus the integral of 2 e to the t dt. Now that is simply equal to t squared e to the t minus 2t e to the t plus 2 e to the t.